Hey everyone, it's that math magician. On this video, we're going to take another look at prisms, but this time we're going to see, can we find the surface area for a triangular prism? Now, if you haven't yet watched my first video on prisms, I highly recommend that you check that out because I define and introduce what prisms are, and it's super important before we get into this that you understand what a prism is. But if you have watched that video, we are going to jump right into this example problem where we have a triangular prism and I want to find the surface area. Now remember, surface area for any prism that we're talking about refers to us finding the area of all of the sides of our three-dimensional shape. So with this triangular prism, what we're going to want to do is we're going to not only want to find the area of the base triangles, right? There's a triangle on the top, there's a triangle on the bottom. We'll need to find both of those base shapes area. And then after that, we'll have to find the remaining sides around the shape. Well, with a triangular prism, there are actually three sides to that shape. Notice that the three sides that are left over are all actually rectangles. Right there, we could call that like the front side. It's like the slanted side. That right there is a rectangle. We have the rectangle in the back, which again is also a rectangle. Then we have this side here that's really just like the right side of this shape is again another rectangle. So to find this surface area, we're going to have to find the area of, it looks like, three different rectangles plus the two triangles that make up the top and the bottom. So let's jump right into this problem then. Let's first start off with finding the area of the triangles. Remember that the triangle on the top and the bottom are the same. It is a prism. Prisms have the same base shape on the top and the bottom. So I really just have to find the area of one of those triangles. Well, area formula for a triangle, that is base times height divided by 2. I see that the base of this triangle is 3 centimeters times the height of that triangle, which is 4 centimeters, all divided by 2. Well, 3 times 4 makes 12. 12 divided by 2 is 6. So the area for one of those triangles is 6 centimeters squared. But that is enough for us to understand that the top and the bottom are both 6 square centimeters. Really good. All right, next up is we got to start finding the area for one of those rectangular sides. So I'm going to go ahead and try and color code this to the best of my ability. I'm going to find the area of the rectangle, the red rectangle, and we know that that will just be base times height. Let's go ahead and make the back side the red rectangle. So give me a second as I trace this out. We want to find the area for this red rectangle in the back. I'll even shade it in so you can see that. That back side right there, that is the side that we're trying to find. Well, base times height. The two side lengths for this rectangle. I see that the top side is 3 centimeters. So I know I'll be incorporating 3 in there. Now I gotta find the height or the length of this rectangle. Notice that what I'm showing right now, this height right here, that is actually the same height as the entire prism. And so over here, I see that the height of the prism is 9 centimeters. That means that this height for this rectangle is also 9 centimeters. So when I'm finding the area for this, I will just have to take 3 centimeters and multiply it by 9. 3 times 9 gives us an area for that back rectangle of 27 square centimeters. So we're almost there. I got one rectangle. Now I got to find the area of another rectangle. Let's do this. Let's go with the rectangle on the right side. Let me go ahead and trace it out so we can see that. This side rectangle here, we're trying to find the area of this guy. Again, surface area means that we add up all of the areas for every single side. Well, this guy I think is going to make a little more sense for us because I can see clearly what its base and the height is for my green rectangle. I see that its base is 4 centimeters, and again, as you'll notice with all these rectangles, the height is 9 centimeters. So I just have to take 4, multiply it by 9, we end up with that green rectangle having an area of 36 square centimeters. Almost done. Now the last one here is going to require a little extra help for us. We need to find the last rectangle. That last rectangle is this one right here that I'm highlighting in yellow. Think about this as like the diagonal side. It's maybe the front side, however you want to word it. We got to find the area of this rectangle, and I'll highlight it so we can keep track of all the ones we've done. Now it's still a rectangle, so that means I'm going to be multiplying base times height. And just like with every other rectangle we've done so far, I see that the height is 9 centimeters. But notice that I don't know what this base side here is, right? Even on the bottom, I don't know what that is. Now, I do recognize that that side right there is the hypotenuse of this right triangle. And that's a right triangle where I know the values of the other two legs. I know that one of the legs here is 3 centimeters, the other is 4 centimeters, but I don't know the hypotenuse. Well, since this triangle here is a right triangle, we could just use Pythagorean's theorem to find out what that missing side length is, and then be able to use that missing side length in our area formula to come up with the area of our front rectangle. We can't get this area unless I know that missing side. But thankfully, we do have Pythagorean's theorem, which can assist us here. So I'm going to scroll over here, and I'm going to quickly work out a Pythagorean's theorem problem to find this missing side. So I'm going to do 3 squared plus 4 squared equals, I'll call that x squared. Well, 3 squared is 9, 4 squared is 16. Add those two together will make 25. That's what x squared equals, but I want what x equals, so I'll have to square root 25. That missing side length there actually ends up being 5 centimeters. I'll go ahead and label the one on the bottom here. They are the same at the top and the bottom. Notice though that by using Pythagorean's theorem, I was able to determine that missing length. Now, some of you out there might have recognized it already, but that's just a Pythagorean triple. That's a 3, 4, 5 triangle. So we really didn't have to do this. But sometimes those triangles on your top or your bottom bases, they might not be Pythagorean triples. So just remember that if you're given two sides of the triangle, you can use Pythagorean's theorem to find that missing side. So anyway, we have that side that's 5 centimeters. We're going to go ahead now and plug that back into our area formula. We know that that missing side there is 5. 5 times 9 gives us an area of 45 centimeters squared for our front rectangle. We now have all of the pieces we need to determine this triangular prism's surface area. So let's go ahead and do that. For surface area, I just need to add up all of the areas for all the sides. Now the top triangle, we know that is 6 centimeters. We know the bottom one is also 6 square centimeters, my bad. Now let's add up the rectangles. The red side is 27. The green side was 36. And the highlighted side was 45. To find the total surface area of this triangular prism, we just have to add up all of these sides together and we'll figure out that number. So 6 plus 27 plus 36 plus 45 ends up with a total surface area of 120 square centimeters. That right there is how you determine the surface area for a triangular prism. Get the area of the two triangles, one on top, one on the bottom, and then find the 3 rectangular sides for this prism. Now, again, you might have to find a missing side on that triangle, but thankfully it is a right triangle, and we know Pythagorean's theorem is going to be super helpful in those situations. It's That Math Magician, and I'll see you on the next video.